introduction. So slabs. So now, what is a slab? Slab is the most common structural element used as the floor or roof in a structure. So each and every building will be having a slab element. So either it can be used as a floor because above it, if any other floor is there, the slab below you becomes a floor. Whereas if it is the topmost level, that becomes a roof for the structure. And slab is a covering element which covers the entire structure, and its design is very much important as it is a massive element. Slab is one of the biggest element because when we say beams, those are all individual elements. Whereas slab, it is a monolithic element which is casted all together, and it's a big element. Then further, slabs can be flat or sloping type. Now, generally, it depends on the monsoon or the rainy season, how much rain occurs and all. If you are in Konkan side or if you are in Goa side, okay, it is mandatory that the newly constructed houses should have a sloping type of roof. Bungalows and all maximum will have the sloping type of roof. It is because of the heavy rainfall in that area, so that water can be drained off easily. In our part of the state, it is not that mandatory because we have moderate rainfall and we generally go with flat roofs. But whereas if you go along the coastal line, it is mandatory that you have maximum houses with the sloping roof. Anyone from Goa available here? Deepesh, are you there?
Yes, sir.
Yeah, this thing you have seen?
Yes, sir.
Yeah, I think maximum of the houses surrounding you in your place will be having a sloped roof, right?
Yes, sir.
Yeah. Anyone else from Goa? Is anyone else available?
Yes, sir.
Who is there? Rasha.
Rasha.
Yeah. You also must have seen, right? Maximum
Yes, sir.
houses are having sloping roof. It is because of
Yes.
the heavy rainfall because it's a coastal area. Okay. So if you are designing at your place, you have to design sloping roofs. But here generally we study flat roofs. And I'll tell you what will be there in the syllabus that practically will be not applied itself unless and until you get trained under an engineer who has worked on the site. You visit sites and you see how execution occurs. You will not understand the principles of RCC design. I'll be ready to help you all. I can help you all in any way which I can if you are interested further. So I think 3 to 4 people who had visited the site. I think no one is present here. Somia is there. Shreyas is there. Veena, no. Those three had visited a site wherein they got to see actually before casting how the reinforcement is put, what are the types of slabs. Similarly, if you all also want a site visit, you can text me the area in which you are staying, especially if it is Belgaum. In and around also text and keep because I have many contacts. Many of my friends are practicing engineers and I can ask them to guide you all, okay, or arrange a site visit. Even people from Goa also, if you require anything, you can tell me. Our students are working there. We can ask them to guide you all practically as classes are not happening. At least if you visit the site, you will be able to see the structures. Other people who are attending the class, who are from in and around Belgaum, can text me your areas or the place where you are staying. So if any work is happening in and around that area nearby to you, I'll take the permission and I'll inform you all so that you can do a practical site visit. So moving ahead, slabs are designed as plate elements as their thickness is very less as compared to the other two dimensions. Now mark this point. This point will be very, very important that slab is a plate element. Now when we see beam, beam becomes a box element. Okay, because width and depth are there. Whereas in case of a slab, the depth or the thickness is very much less compared to the length and the breadth. So we design a slab as a plate element. So remember this point, slab is designed as a plate element. Okay. You don't find a slab which is too thick. Okay, generally the thickness for residential building will be from 100 to 200 mm, and if it is used as a deck slab for a bridge and all, thickness will be above 200 mm. Else, slab is a plate element, whereas beams are considered as box element. Remember this point very much carefully. Then further, it resists the load by flexure action. Now, what do you mean by this flexure action? Flexure is nothing but bending. So it resists the loads by bending action. Okay, it undergoes bending and it resists the load coming on it. That means once flexure comes, our normal formulas come into picture. That is WL square by 8 and all those formulas which you have used from song come into picture once we say that the load resistance is by flexural action. Flexure action means simple bending action. Then the slabs generally support vertical loads. We don't design slabs for horizontal loads. Okay, generally the loads coming on the slab are vertical only. Okay, the load is applied from the top. For example, on your slab, you will fit the tiles. Now that tile becomes a type of a load. On the slab, you are placing so many things. On the floor, you are placing so many things. Okay, cupboards are there, books are there, shelves are there, racks are there, furniture is there. Those all comes under the dead load which is placed on the slab, whereas the human load is taken under live load. So for loading, we refer IS 875 code books. Okay, IS 875 part 1, part 2, part 3 for live load, dead load, seismic load, wind load, etc. Okay, so remember the code book for loading, we refer IS 875 part 1, 2, 3, 4 for your loadings. Then generally the thickness of the slabs for building is kept between 100 to 200 mm. So now whenever we'll be designing the slab, we have to keep in mind that our thickness of the slab generally will be between 100 to 200 mm. Preferred is minimum is 125, which becomes 4.5 inches, which is better always. Minimum that much we keep practically, but theoretically it is like we can keep a thickness between 100 to 200 mm. So when you are designing, see that the depth of your slab doesn't go beyond 200 mm for a building. 200 also is quite big. Maximum times when we have practically designed slabs, big slabs also, they fit in 6 inches, which is 150 mm. So whenever you go on a site, first observe how much is the slab thickness. So this is what is a slab. And next is we'll try and discuss about classification or types. Sometimes a theory question for 4 marks or 5 marks, this question is asked. Give the classification of slab or name the different types of slabs. So slabs can be classified as one-way, two-way slab, flat slab, grid slab or waffle slab, ribbed slab, and circular slab. So these are the basic 6 type of classifications. Further, we have irregular shaped slab, cantilever, etc. All those will come. But these are the basic 6 types of slabs which we see in and around. So out of these 6 types, for your syllabus currently we have one-way and two-way for your design. Now this comes if you take the elective advanced RCC. Now this is very much important currently in the practical things. Flat slab or say waffles, grid slabs, these all are used in commercial structures very much regularly. If you visit any airport and all, you'll be able to see ribbed or grid slabs, which is quite regular. Okay, flat slabs are preferred in commercial structures, your theaters, etc. Okay, but that is not a part of your syllabus. What we'll study is these two. In this itself, one more part can be done is continuous one way and continuous two way, but that also they have not mentioned in your syllabus. So your syllabus has only one way slab and two way slab, but practically this application has increased a lot. So if you want to study flat slab and all, the elective such as advanced RCC should be taken by interested people who want to study more things in detail. So these are the six type of basic slabs. Now I'll be showing you all the images and trying to tell you what are the things which are different from one another in these six types of slabs. So I've collected images so that things will become easy for you all to understand. So first, let me start with the one-way slab. Now, generally, what do you mean by one-way is your main reinforcement will be along the shorter span. One-way means your main reinforcement will be along the shorter span and your distribution reinforcement will be along the longer span. That's it. Okay, so now if you see this image, in the one-way slab, we have basically two supports. Here you have one support and here you have another support. These two supports are supporting this slab. Okay, there is no support here. Here there is no support. Similarly, behind also below this, there is no support. So one thing you have to understand is when we have only two supports, then we got to go for a design of one-way slab. So what is happening here is this is your reinforcement. Okay, this is your reinforcement here. Change the color so that you can see it easily. See this. This is your reinforcement. And what happens here is the bars will be bent and they'll go inside this support. See here. One bar comes like this. Here it bends. Then it goes straight. Okay, it goes straight. Then the other bar will be there, which is bent this side, comes, it goes straight. This is alternate bending. One after another, you will have the bending done, which is a one-way slab. Okay, so these bending, I'll be telling you all once again when we solve an example. Whereas if you see, these are your distribution bars, which will be coming straight. There is no bending provided in these bars, and these will be along your longer span. This is your one-way slab. One-way slab means your main reinforcement will be in shorter span, only one direction. That is termed as your one-way slab. So you can see here. Okay, one bar has gone like this. Other bar here is straight. Then next again, one bar is bent. Other bar is going straight. Okay, so this is nothing but alternately bent. Okay, so that the bar gets anchorage into the support. So this is what. And as this bar is bent up here, the bar which is going straight will be bent on the other side. This is what is called as alternate bending. So when we want to describe it, so this will be one bar is bent here, other bar, this side will be moving straight, and again it will get bent here, this side. So alternately, one after another, bars will be bent in alternate direction. So this is a one-way slab. So how you recognize a one-way slab? Generally for a one-way slab, support will be there only on two sides. Okay, not all on the four sides. Only two sides support will be there. Then second thing is you will have main reinforcement along shorter span, which is alternately bent. Main relation along shorter span. Whereas the distribution reinforcement will be along the longer span, which will be straight. Now these all are distribution steels, which are straight, and these are along the longer span. So this is what is a one-way slab. So maximum slab in residential building, we try to give it as a one-way slab. Now how we take the slab as one way in the further discussion, we'll come to know. So this is what is your one-way slab. Now moving further, this is your two-way slab. Now what happens in two-way slab is, see here, if you observe properly, you'll find that we have supports at all the corners. This is one support, and from here the beam is going. Okay, means slab is, again, this is a beam which provides a support. Again, here there is a beam which provides a support, and this is one more beam which is providing the support. Means in an two-way slab, we have all the four corners which are supporting the slab. Okay, we have all the four corners which are supporting the slab. Whereas in one way, we saw that there were only two sides which were supported. Now, as we say, it's a two-way slab, bending will be happening in both the directions. So now, as it's a 3D image, it will be a bit difficult. Don't worry, I'll try and explain. Now, see, this bar is bending here, whereas this bar is bending here. Okay, so what is this? Bars are bending in both the direction alternately. Okay, bars will be bending in both the directions alternately. This is nothing but your two-way slab. So this is bent, this bar is coming straight. Next alternate, this is bent, then next bar is coming straight. So alternately bent on both the sides. The bar which is coming straight here will be bent this side. Alternate bending in both the directions. So one-way slab, main reinforcement in only shorter span, alternate bending. Two-way slab, main reinforcement in both directions with alternate bending. This is your one-way slab and two-way slab. Next, we come to the most important type, which is a flat slab, which is used nowadays. Now, see here, this is the arrangement of a flat slab. You will not have any beams. Okay, there are no beams connecting the columns. Okay, there are no beams connecting the columns. Now, if you see in your residence where you are, you will find that there will be beams here. Slab will be supported by the beams. But flat slab are those slabs wherein we don't have any beam grids. Directly, there is a column. Above that, there is a column head. Okay, this is termed as column head. And over this column head itself, the slab rests. Okay, the slab is resting on this column head. So here you have one, here you have one, same everywhere. Okay, you don't have any beams in between. It is a slab which is free of beams. So this is very nice and very important, because if you are say in a theater and the span will be very much big in a theater, and you are sitting, imagine this is a theater room, and if you are sitting and watching a movie, and if beams are there here connecting the columns, your vision will be blocked. Okay, you will be not be able to see the screen very much properly. So in the such cases, in case of commercial structures, what you do, you go for flat slabs. So from next time, whenever you go out for shopping and all in shopping malls or in theaters, you try and observe these things easily. So what is a flat slab? It is a slab where it is free of any beams. Directly, the slab rests, the slab rests on this column heads. These column heads are in turn supported by the columns. Okay, so this is what is your flat slab. Actually, these designs are very interesting. We had it in our electives when we were studying in advanced RCC. So next semester, I think you also will have those electives. Now moving further, we have something called as grid slab. Now this is very easy to understand. See this formations. It's grids. Okay, grid, ribbed, waffled are somewhat similar. So we are having a grid here. Okay, so this is very well planned grid. This is what is a grid slab. Again, this comes in the advanced RCC design, and these are very commonly used in hotels and all, where we have electrical arrangement in these blocks, nice lightings and all will be there, POP will be done. So these are your grid slabs. For longer spans, these can be used very much nicely. Then we have one combination where we have a flat slab plus grid slab. Your airport and all have such structures. Then we have grid also given in a shape. Again, this is resting on this column head. There are no beams. So this is a example for flat and grid slab combined. Imagine how beautiful will be designing such structures. Then next is a ribbed slab. So ribbed in the sense it is again as I said, it is similar to your grid, but your grids are bigger here, which is the rib. So we have a rib cage in our body. Similarly, these are your ribbed slab. So in this, if you are finding ribs are only along one direction. There are no ribs in the other direction. Okay, there are no ribs here. So this is a one-way ribbed slab. Okay, this is a one-way rib slab. Whereas when you go here, you see that ribs are here, and as well as in the horizontal direction also ribs are there. So this is nothing but your two-way rib slab. These all observations I think from now on you should be able to do whenever you go to any function in a marriage hall, Mangal Karalaya, or any big structure. Just observe what type of slab they might have given there. So this is your ribbed or ribbed one-way and ribbed two-way slab. Now next is your circular slab. Okay, many times the structures such as domes, stadiums, or your basis of the water tanks have circular slab. Okay, so these are the example. Again, I have here example of ribbed circular slab. See how beautiful it is designed. Okay, it is a ribbed circular slab. So these all things are very, very interesting if you go in design. If you concentrate and study the basics here, it will be very much helpful. So see how will be the reinforcement place. Once you get a circular section, you will get something called as hoop stresses, which will be induced. Now think of the big structures. Don't think of a G+1, G+2 buildings. Okay, think of the structures which are mega structures, multi-storied buildings. And if you go ahead in the designing field, these all things will come across at one point or the other. So these are your circular slabs. Maximum of our water tanks, elevated water tanks, which we see are circular, and design of circular slab is very much similar to that of a flat slab or your regular slab. But some more stresses are induced because of the curvature. So this is the example of your grid slab or circular slab. So this were the images of different types of slab. So we'll come to the last part of today's class, which is the difference between one-way slab and two-way slab. As we are studying one-way slab and two-way slab in your syllabus, we'll be focusing more on this part. So one-way slab, two-way slab. Now this is the first thing which you should know. A one-way slab, the ratio of longer span to shorter span is greater than 2. And for a two-way slab, the ratio of longer span to shorter span is less than or equal to 2. Now, see here. For example, I have kept the Ly dimension as 8 meters or 8 units and Lx as 3 units. So when we take the ratio of longer span to shorter span, that is 8 by 3, I get 2.66, which is greater than 2. So this I can design it as a one-way slab. Okay, this I can design it as a one-way slab. And this what I'm marking is the notation which will be used by structural engineers to denote the one-way slab. Sorry. This will be the marking along the shorter span. They'll give this. So on your drawing, if you read this mark, that means this slab will be a one-way slab. Okay, this slab is a one-way slab. Why? Here the ratio of Ly by Lx is greater than 2. What is Ly? Ly is the longer span. What is Lx? Lx is the shorter span. So if the ratio is greater than 2, we are designing this as an one-way slab. Whereas when we come to the other side, what we see here is ratio of longer span to shorter span is less than or equal to 2, we design that slab as a two-way slab. So when we see here the ratio, one side is 4 units or 4 meters, other side is 3. When you divide 4 by 3, we get something 1.33. Okay, we get 1.33, which is less than 2. Okay, now this is the difference. This is less than 2, and here when we come, this is greater than 2. So as this is less than 2, we have to divide it as a two-way slab. Now, two-way slab means both side main reinforcement, alternate bend. One-way slab means one side main reinforcement, other will be distribution reinforcement. Now, as a structural engineer, how will I denote this is? I'll denote this like this. Now, if you see this notation, what you have to conclude, this has to be a two-way slab. If you see this notation in the structural plan, you have to say that this is a one-way slab. So this is the first thing or the first difference or definition of one-way slab and two-way slab. That the span, sorry, longer span to shorter span ratio should be greater than 2, or longer span to shorter span ratio should be less than or equal to 2. One-way slab is greater than 2 and two-way slab is less than or equal to 2. So these are the notations which are followed by standard structural engineers. Then, now this point again, if you are having a pen pencil, note it down. When we design the structure practically, okay, a residential building and all, many times what happens is we have rooms of size say 10 feet by 10 feet or 10 feet by 8 feet. Okay, so 10 feet by 8 feet goes as 3.1 meter by say 2.7 meters. So 3 divided by 2.7 comes as less than 2, but we don't design a two-way slab there. So the thumb rule says that up to 10 feet, if one side is there, we can go with one-way slab in that direction. Means if you have a room by of size, say 10 feet by 12 feet, okay, your bedroom will be of that size, generally 10 feet by 12 feet. So as per the textbook or as per the regulation or as per the theory, when we divide 12 by 10, we get answer 1.2. Okay, 1.2 is less than 2, hence it has to be designed as a two-way slab. But no, we practically don't do it. We provide the slab as one-way slab itself, spanning along the shorter span. Okay, along the shorter span. So always remember that two-way slab becomes heavy because main steel has to be provided in both the directions. So up to 10 feet or in residential building, how much ever possible, we can try and avoid a two-way slab. Otherwise, the steel will become very heavy and the structure will become quite costly. So remember this practical thing. Anywhere if we are near 10 feet, practically provide the reinforcement in that direction. So if you have a room of size 16 feet by 10 feet, okay, if you divide 16 by 10, again the ratio is 1.6, which indicates it's a two-way slab. But practically there is no need to provide a two-way slab. You can directly provide a one-way slab spanning in the shorter span. This you have to do only practically, not in the examination. In the exam, you have to follow this rule strictly. Ly by Lx greater than 2, Ly by Lx less than 2. Then further, one-way slab supported generally on two sides. It might be supported on four sides also, but generally a one-way slab is supported only on two sides. Whereas a two-way slab compulsorily should be supported on all the four sides, as reinforcement is main reinforcement in both the direction, and it has to go inside the support. Hence, the supports have to be there on all the four sides. Then in shorter, this one-way slab, main reinforcement is provided only along the short span, whereas in a two-way slab, the main reinforcement is provided along both the spans. So these are the major three differences among the one-way slab and two-way slab. So in today's class, what we have studied is we have first defined a slab, we have understood what is a slab is, then we discussed about how the load will be coming on the slab and concluded that slab will resist the load by its flexural action. So after that, we discussed the different types of slabs which are commonly used. Further, we saw the images of those slabs, and after the images, we came to one-way slab and two-way slab and understood the difference between the one-way slab and